Hi, I'm Nur Amalia Barkis binti Muhammad Zabidi and my metric number is 2022820334.
Hi, my name is Nur Alia Atira binti Muhammad Zailani and my matrix number is 2022487942.
My name is Aini Hani Azani binti Abdul Aziz. My metric number is 2022628548.
Hi, for this video we are going to talk about the experiment that we choose, which is tossing a coin. There are three objectives for this experiment. For the first one is to record the different heads and tails result that might be selected. The second one is to calculate the probability of getting heads and tails after randomly tossing a coin 30 times. And last but not least is to understand the distinction between theoretical and experimental probability. This experiment is important because it will teach us more about probability and how to use it in everyday situations. This project consists of involving tossing a coin. As a result of this experiment, we can calculate the probability that a coin will land in the heads or tails positions. Moreover, theoretical probability and experimental probability may both be better understood. We will see that the experiment outcome is the same as the difference between the theoretical and experimental odds of tossing heads and tails.
Hi, I'm going to explain to you the method for this experiment. First, decide which side of the coin is head or tail. Second, putting your thumb up, make a fist. The finger that will propel the coin into the air is your thumb. To make the coin go up, make sure it is facing up. Third, place your thumbs each beneath your index fingers. When you bring your thumb up for the toss, this will give you a little resistance, helping create a quick move to strike the coin. Fourth, place the coin over the gap created by your thumb and index fingers. It should sit on top of both fingers and not fall off. You should not hold the coin in place when you flip it, so it needs to sit there without help. Fifth, lift your thumb quickly. This snap motion will push the coin into the air, causing it to flip repeatedly. Gently doing will give a softer toss, meaning the coin will spin fewer times. For the next step, watch the coin in the air, then catch it to see which side came up. Next, record the result, and repeat step 1 to step 6 for 30 trials of toss coin.
Now, let's discuss about question A. As you have seen from previous coin toss video, this is a table that shows the result of getting heads and tails for 30 times. From the table, result of getting head is 17 times, while the result of getting tails is 13 times. Question B needs us to find the experimental probability of getting heads. Formula for experimental probability is number of times event happen divided by total number of trials. From that, we can conclude the experimental probability is 17 per 30. Next, find the experimental probability of getting tails. The formula is same with the previous slide. Hence, the result for the experimental probability of getting tails is 13 per 30. Question D asks about find the theoretical probability of getting heads. Theoretical probability can be found by number of favorable outcomes divided by number of possible outcomes. Here we have number of favorable outcomes is 1 and number for possible outcomes is 2. So the answer for this question is 1 over 2. What is the theoretical probability of throwing tails? Like a previous slide, we have 1 for the number of favorable outcomes and 2 for the number of possible outcomes. So the result for the theoretical probability of throwing tails is 1 over 2. So for this question, we know that the data for experimental probability is 17 over 30 and the data for the theoretical probability is 1 over 2. So we can find the difference by minus the theoretical probability with the experimental probability. From the answer, we will get the percentage by times with 100. So here we have 6.67% as the answer. Lastly, the question asks what is the difference between the experimental probability of throwing tails and the theoretical probability of throwing tails. From the previous data, the experimental probability is 13 over 30 and the data for the theoretical probability is 1 over 2. So after we minus 1 over 2 with 13 over 30 and times with 100, we get negative 6.67%.
To sum up, our group is working on experiment 1, tossing a coin. We use the method to toss the coin 30 times in order to determine the number of head and tail results. The coin will occur then had a frequency 17 heads and 13 tails. We can determine the experimental probability of receiving heads and tails after obtaining the frequency. The theoretical chance of tossing heads and tails may also be found. Next, we may determine the discrepancy between the theoretical and experimental probabilities of tossing heads and tails using the same concept. Furthermore, after conducting this experiment, we can say that there is a greater chance of getting the head than the tail. Consequently, the percentage required to get the difference between the theoretical and experimental probabilities of tossing heads and tails is equal to that of throwing heads. Overall, we have a greater knowledge of this topic's notion after conducting this experiment. We also learned the proper methods for tossing a coin. Not only that, but also we clearly understand the calculation and solutions to solve a few questions related to these topics.